Hey there, let's go ahead and look at adding and subtracting fractions. The first thing that I want to do is show you, or to remind you what a fraction is. If we had the fraction 1/2, we would be talking about the numerator here when we say this is the number of parts we have, and the denominator is the number of parts in a whole. So if we were going to draw this 1/2 as a shape, say for instance we were doing a circle, we were talking about a pizza or a cookie, it is broken into two possible pieces, and we are concerned about one of those two pieces. This is 1/2 of a pizza. All right, so now if we were talking about adding together some fractions like 1/2 and 1/2, this works perfectly because we are adding together shapes that have the same number of pieces in the whole. So what we would do here is we would literally count our halves. We have 1/2 in green already on our pizza. If we were going to add another half, we're going to say this is the pink half. We would have 1/2 plus 1/2 equals 2 of the possible 2 pieces in this whole. The whole here does not change. The denominator then does not change because we have the same size pieces, the same number of pieces in the whole. Because they both have a 2 as the denominator, we can add them together easily. Now, this is an improper fraction because it can be represented another way. 2 over 2 really does mean that we have one whole pizza. All right, let's go ahead and look now at adding a new type of fraction. So say, for instance, we were looking at the fractions 2/6 plus 3/6. When we're doing this, remember we have the same number of pieces in the whole. In this particular problem over, or portion over on the left, we're talking about 2 out of 6 pieces, and over on the right, we're talking about 3 out of 6 pieces. So what we're going to do is we are going to count all of them. We have 1/6 here, 2/6, 3/6, 4/6, 5/6. We literally have 5 different portions of a pizza that is cut into 6. Perfect. There is no way to simplify that. There is not a number outside of 1 that would go into both of those numbers evenly. Simplifying is the same as reducing in this instance, making it the smallest possible fractional numbers. So let's look at the next one. Let's say, for instance, we were talking about a fraction like 2/5, and we were trying to add it together to 4/10. This is something that we cannot do because the size of our pieces or our pizzas are not cut into the same size pieces, so we can't put them together. It's kind of like putting jigsaw puzzle pieces from a 5-piece puzzle, trying to put them together with a jigsaw puzzle that has 10 pieces within the whole puzzle, and those are going to be different size pieces because of the different number of pieces that are included within that puzzle. So because of that, what we need to do is we need to actually change one of these fractions to have the same denominator, if not both of them, to have the same denominator as another one. So in this case, because 10 over here on the right is larger than 5 over here on the left, I'm going to ask myself, is there a way to turn 5 into 10? Basically, we're saying, is 5 a factor of 10? Can we in some way multiply or divide one way or the other to turn this 5 into a 10? So I can count by 5s until I get to 10, see if that's possible. 5, 10, I counted 5 2 times. That means I'm using 2 groups of 10. So what I'm going to do is I'm going to rewrite my 2/5 as something over 10. Why? Again, because I'm trying to make sure that my fractions have the same size pieces, that they have the same denominator here. So what am I multiplying by? To go from 5 to 10, I'm multiplying by 2. If I multiply on the bottom, I need to multiply on the top. We can't just cut the number of pieces in our whole by 2 and cut them into 2. We have to also cut the pieces that we have, aka our numerator, into the same number of cuts or number of pieces. So 2 times 2 for our numerator is going to be 4. Now my next step, first step, change to the denominator. Second step is going to be rewrite our problem. So our problem in this instance now, I know that 2/5 was changed to 4/10, so I'm going to rewrite it 4/10, and I'm going to add the next portion, the next addend was 4/10. I only add by numerators because remember we have the same numbers in the whole, we have the same denominator then. So we're adding just the portion on top. 4 plus 4 equals 8. And we still have 10 pieces in our whole. The problem here is solved. So we were able to change the denominator. We rewrote our problem. We were able to solve the problem. Now we need to simplify. So simplifying means that we need to find something that is able to be a factor, is divisible within both of the parts of our fraction, the numerator and the denominator. And looking at this, I have an 8 and I have a 10. I can try 1. That's a waste of our time because it would be the same thing. We could try 2, and I know that it is 2 because 2 is a number that becomes a factor of every even number. 8 is an even number, so it's divisible by 2. 10 is an even number, so it is also divisible by 2. All right, so 8 divided by 2 for my new fraction is going to be 4. 10 divided by 2 for my new fraction is going to be 5. What does that mean? That means that we took our pizza that was cut into 10 pieces. That means we originally had 8 of them. 1, 2, 3/8, or 3/10, 4/10, 5/10, 6/10, 7/10, 8/10. And we are saying, hey, this looks like we can group these together in some way. If we take 2 of these pieces and make them 1, how many groups would we actually be talking about? Here's a group of 2, here's a group of 2, here's a group of 2. Just kidding. Here's a group of 2. Here's a group of 2. Let's do that in green so you can see it. Here's a group of 2. 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 And here's a group of 2. Well, how many are we actually using at this point? You have 1. We have 2. We have 3. We have 4 out of 5. Really quickly, let's look at subtraction. We follow the same exact steps. Let's look at something like 7/14 minus 2/7. So our first step, again, is going to be to find that common denominator. Our denominators here are 14 and 7. Well, is there one that's greater than the other one? Yes, 14 is greater than 7. Because of that, we can say, we can look and ask, can we turn that 7 into the other denominator, that 14? Well, yes, we can, because I can count by 7s till I get to 14, and that's even. I count by 7s 2 times, so I'm going to rewrite this as 2/7 over something over 14. What did I multiply by to get to 14? 7, 14. I counted 7s 2 times. That means 2 groups of 7 multiplying by 2. Multiplying by 2 on the top, because if I do it to the bottom, I have to do it to the top. 2 times 2 is 4. Now I get to rewrite my problem. I'm going to rewrite my problem here. 2/7 I turned into 4 over 14. I'm going to keep 7/14 the way that it is, and I'm keeping the same sign. Now I am at 7/14 minus 4/14. I can literally just look at the top portion of it. I am only changing the numerators because I cannot change how many parts there are in the whole. So 7 minus 4 is going to be 3, and there are still 14 pieces in the whole. This cannot be simplified. So I have my step 1 is figuring out if I need to change my denominator or not. That's the whole top portion of that. Step 2 is rewrite. Step 3 is solve. And step 4 is simplify, which I cannot do here.